Let's discuss question number 16 from test 1. This is basically from IC engines, so basically the applied thermodynamics or broadly under thermodynamics. Okay, so keeping other parameters constant, the brake power of a diesel engine can be increased by, so density is temperature of intake, so everything about the intake air it is asked. Okay, now brake power, that's basically the power which you measure at the output shaft. Now this power is basically dependent on the torque into the speed, okay, the 2 pi nt by 60 whatever, torque into omega, so 2 pi nt by 60 is your brake power. Now if you just recall, the brake thermal efficiency is basically, or the brake thermal efficiency, or you can say, or the total efficiency combined, the total efficiency is basically mass of the, so this is basically the input energy of the fuel, the mass of the fuel burnt into calorific value, and the output what you are getting is the brake power. Now this is more or less constant for an engine, the combined or the total efficiency. So now brake power can be increased basically by increasing the mass. So or the other way of, the other way of analyzing is this brake power I can just write in terms of brake mean effective pressure into the stroke volume. Okay, so this is basically work done in a cycle, and number of cycles, if it is a 2-stroke engine I can write n by 2. So now if my brake mean effective pressure is more, my brake power will be more. Now how my brake mean effective pressure can be more? Well, if I take more mass of air in a SI engine, if I take more mass of air or more mass of air fuel thing in a SI engine at the start, so for a given volume and a given temperature, if more mass is there, I can say the pressure is increased at the start of the compression. Now at the start of the compression if pressure is more, so at the end of the compression pressure will be more, because they are related by your, so pressure here and pressure here are related by means of compression ratio. So if the start the pressure is more, so at the end the pressure will be more because of your compression ratio. Or basically you are taking more mass at the inlet. If you have more pressure, basically it means that there is more mass of air fuel at the start of the compression, and basically you are burning more mass of fuel in the combustion chamber, and that's why you get more power. Basically the mean effective pressure is increased. So the option is increasing the pressure of intake air will increase the mass in a given volume of the cylinder. It will basically increase the mass of fuel or mass of air fuel mixture, okay, that is in a SI engine, whereas this applies to in a diesel engine also. So in a diesel engine basically if you take if you increase the pressure of intake air, you're taking more air, and there will be a complete combustion then, and basically produce more power. So it's basically the option is C, increasing the pressure of intake air. Thank you.